This is a production of Cornell University.
So thanks everybody for taking the time to join us. And as you can see, we're pretty casual about this, but not casual about the information. I don't know if you can see this in the background, but just a few weeks ago, I was standing right where the earth is separating here between North America and Europe, up in Iceland. This is about a mile from where the current eruptions are occurring. And there's a golf course there that we got to visit. So it's wonder if it's going to be earth shattering this morning. I'll show a couple of fun pictures of my spring so far. I got to hang out with the 82-year-old Miss Stewart recently on her property in Bedford, New York, and that was a joy of a lifetime. And I've had a pleasure of working with this guy for a lot of years. And I guess, Art, you gotta unmute yourself. So you got to take us through which is which here. Was this back in the School of the Mine days?
I think that was right when I got to Cornell, actually. Boy, that was something I did actually with Dave Wolf, I remember. Wow.
Yeah, how about that? Anyway, so listen, we listened to you this morning, and I want to talk about I'm going to use you right in the beginning here, just like we do in the call, and then have you linger around with us as we talk about things moving forward. And like you said this morning, as climatologists, you guys think about the winter as December to February, and just looking nationally. So when I look at this nationally, right, and you see that period is among the warmest ever, but then you look out west and see that it's cold out there. Is that the shift in the jet stream? What the hell is this about?
Yeah, that's exactly the case, Frank. I mean, if there's record warmth in the east, boy, there almost has to be record or at least cooler temperatures in the west. That's the typical like wavelength of the jet stream. So this is showing me that across the winter there was a strong ridge set up, basically east of the Mississippi River, and the corresponding trough was over the west coast.
Right.
And I mean, if you think about all those big snowstorms that hit the Sierra and things like that, that's a manifestation of that.
Yeah. And then it's been a really warm start to the spring, right? It was last year a really warm start. This was last spring, a really warm start.
Spring, yeah.
But what I don't have is the wet. But what I do have is the cloudiness, right? This is Brian Bretschneider. I don't know if you know this guy, but let's take a minute and talk about the moisture we get through the winter, number one, and number two, how it may not be really helping us as much as we might like.
Yeah. So, I mean, I could say a bunch of things about this map. First off, it doesn't bode well for eclipse watching in a couple of weeks, particularly in upstate New York, because I think that pattern is pretty typical of going into early April. But really what you see here, in some parts, it's a classic El Nino pattern. If you look at Florida with the high cloud cover, and also California, places there where you would think of perhaps it being more sunny in the winter. That's really the track of that jet stream. You have storms coming in off the Pacific Ocean and impacting the parts of the West Coast. So that's pretty common, hence the cloudiness there. And then those storms kind of continue along, across Mexico, across Houston, and then redevelop over the Gulf. So you see the cloudiness across a good part of Florida. And to a certain extent, starting to go up the East Coast. I think one of the things that we saw in this winter that, typically you get a very strong East Coast storm track during an El Nino winter, but kind of missed that. A lot of cases went off to our south, but still a fair amount of cloudiness up through the metropolitan area.
Yeah.
The other thing that kind of stands out is the big black blob up around the Great Lakes. And I'll attribute that actually to our warmer than normal winter, where those lakes were pretty much ice free. So that allowed water to evaporate out of the lakes and gave us the cloudiness.
So let's take a minute and talk about that for a second, the impact that water has. Thanks for bringing that up. We are very much in this part of the country, unlike, Colorado, which might have mountains and, other things. We're impacted by the big bodies of water. The implications of those water bodies getting warmer, is this once I just think about the water like the soil, if it doesn't get persistently cold enough, it's going to keep warming, and that's a big old mass. As that keeps warming, is that a driver of this kind of weather we're going to be expecting, especially along the coast?
That's yeah, that's pretty good. You should teach my class, Frank. Not only the lakes but the oceans as well. So you can
Right.
think of the warmth and how that affects the moisture in two ways. As the ocean warms, as the lakes warm, warmer water can evaporate more readily, so that water evaporates into the atmosphere.
Mhm.
And then as the atmosphere warms, kind of like to talk about the atmosphere as being a bucket for
Yeah.
or a sponge for water vapor. As the atmosphere warms, it can hold more water vapor. So there's really, so kind of more water can evaporate out of the oceans and lakes. The
Mhm.
atmosphere can hold more of that water. Kind of think of that as clouds in this
Mhm.
case. And then, when the weather systems come through, they're the things that squeeze out that water from the atmosphere. So that's why we see heavier rainfall events, right? We're
Right.
always getting these storms coming through and they have more raw material to work with. So we get the heavier rains.
So this is perfect, Carl. So the winter so far makes you wonder about the weather. So it's on you.
Yeah, one of the things I like, Frank, we talk about data all the time. These sort of retrospectives, when you get some space from last year's growing season,
Yeah.
right? Things are getting going here in the spring, and I'm always like, this is a good time to sort of look back at last year and some of the models we have, either disease models or irrigation models or even mowing and growth. We'll talk about that in a second. But sort of like, okay, what was last year like? Now that I've removed myself from it, what did the data say that was like? And can I use sort of my measures of resource use and go back and look back, okay, did that align with what the weather was like? So we have disease models, the Smith-Kearns dollar spot model. We show this data all the time. For those just listening, I've got the last 5 years of this dollar spot model across the growing seasons listed. And I've got this sort of 20% threshold. That's basically when you get above that level, we start to see some dollar spot outbreaks, right? So that's the sort of level where, okay, we'd start to think about treating with a fungicide. And when you look at the last 5 years, this is Ithaca, New York, sort of the date where we cross that 20% threshold is relatively constant. Day 170, that's like June 20th or 25th. That's pretty late. So when I look at that, I start thinking, man, if I had applied a fungicide for dollar spot in June 1st, maybe I was wasting a lot of that, right? So going back and thinking, okay, right around June 25th is when I should have applied. But then look at where it goes back down on that line on the back end in the fall, right? It's a lot more variable. And you even have these years, last year, day 270. So I think that's getting into September. But even 2021, that green line stretches well into October. So we're sort of getting this extended dollar spot period in the fall. And Frank, I can't really remember. I wonder if anyone has told us about fall dollar spot getting worse. And oh yeah, there's a paper by Art DeGaetano and Frank Rossi in 2007 that
Yeah.
says, hey,
In 2000. Yeah.
we expect dollar spot pressure to be shifted towards the fall. And this is a function of right temperature
I
and
hate
relative
it when we're
humidity.
right. I hate it when we're right.
And this is what you see, and the different weather stations show that sort of that fall stretching. So thinking about how we're applying when you made those applications, oh, this is interesting data to look at. And then we've also got this new, we'll come up with a better term for it, Frank, but the Cornell Growth Index, basically a function of how much we think the grass should grow based on temperature and the soil moisture that's present. So things like sports fields, golf course fairways, lawns, right? We're not irrigating them that frequently, but that soil moisture component plays a big role in how much the grass grows. And if you look at 2023, wow, it was a big growth year, especially in that summertime. Not surprising, you guys were out there, you were mowing a ton, and that's because of the soil moisture. We got all that precipitation last year. So what we'd say is, hey, you had to mow a lot more. So maybe if you tracked your mowing events, you would have a high number there. But all of that soil moisture is allowing mineralization of nitrogen from the organic matter, right? So you would have had to fertilize less, right? It's mowing a ton. I don't need to put nitrogen out there. So thinking about, okay, did I fertilize the same amount as 2022? Because you see the 2022 line is the exact opposite. It is a very low sort of growth potential summer, and that's because we had a dry summer,
The
right?
very standard bimodal curve there, right, Carl? I mean, this purple line that, sorry for the people listening on the podcast, but if you go back and look at this, many of us have showed this graph. You see the perfect, what we think about a cool season grass through the season. and it's particularly related to soil moisture, which the model takes into account. So since you're talking about moisture, and Art's been talking about adding moisture to the atmosphere, right, and what that's going to do, we've got some very interesting information here about the way we might be using water and the way we could benchmark ourselves against something.
Yeah, having this idea of benchmarking, we've talked about this in past seasons, right, Frank? Having some sort of number that gives you an idea of, plus or minus, in this
How am I
case,
doing? How am I doing?
yeah, how you doing? Am I within 1 million gallons, right? And this USGA water budget calculator, meant for golf courses, but anybody can use it, right? If you're a landscaper thinking about just on
Right.
a 5,000 square foot property, how much water
Exactly
should
right.
you use? Sports field.
Exactly right.
You just put in basically what was the monthly ET rate, rainfall, and it gives you right to the website where you can get this information. You put in how many acres you irrigate. How much should I have put out there in a given year? And if you go to the next slide, Frank. Oh, did we lose Frank?
No,
There he is.
sorry.
We can sort of make these calculations on a annual basis and then sort of look at them over the years. It's really interesting for Ithaca, New York. If we had about 40 acres we were irrigating on a golf course, man, our water use has been very, up and down each year, right? From as low as 2.7 million gallons in 2021, right? A very wet year. We got a lot of rain. We didn't irrigate. Right up to 8.2 million gallons the following year, almost a four-fold increase in sort of the expected amount of water we would have used. And then you look at last year, 2023, right? A lot of rain. We cut it back down in half, about 4.6 million gallons. So this is really interesting. If you have the ability to go back and look at your water use, are you following these trends, right? The numbers themselves, there's wiggle room in that. But are you following these trends, right? And if you aren't, maybe you got to look at, okay, is there something about my site that's different, that's making me water differently? Or am I just not using water at the right times?
Yeah. And Art, I'm wondering from your perspective, you work with a lot of crops and commodities in agriculture. I don't know how many of them are irrigated, but when you do have irrigation stuff, and I'm sure, farmers probably aren't paying for water any more than a lot of golf guys are, but our sense is that the state's coming for the understanding of the water. They're trying to figure out who uses what and determine what our usage rates are. Cause I don't know maybe we're going to put a pipe to the desert or something. Maybe you know better than I do. What kinds of conversations are going on in other irrigated crops from a climate perspective? Cause you taught us about these dry periods and then intense rainfall.
Yeah, I haven't heard anything about a pipeline, Frank, so I'll leave that where it sits there. But yeah, I think everybody who's growing crops are really looking to irrigation. And, unlike a lot of high quality turf, a lot of the crops, the vegetable crops are, it's kind of hit and miss in terms of the irrigation. So, we talked a lot about more moisture being in the atmosphere. But you have to remember also that the other component of that is some type of a weather system to kind of squeeze that out. So even in the summertime, we do get into these periods of time where we're under a ridge, we're under high pressure, and those weather systems don't come along to squeeze it out. So that gives us this idea of more kind of dry periods in the summer. And really where that becomes more important with warming temperatures and things like that, right? More evaporation is occurring.
Yeah.
So, when it evaporates, when conditions are good for evaporation in the summer, the other side of that is a warmer atmosphere allows more of that water to evaporate from the landscape. The landscape acts the same as the lakes in that case, so more is able to leave it.
Yeah. And so we've been working with you and your colleague Ben at the Climate Center, right, Carl? This is project that the slide we have up now is the new irrigation model. So let's talk about this. This seems to bring everything we're talking about up till this point together here.
Yeah, so we used to have a lawn watering tool, and it was I would call it primitive to be nice, right?
Primitive's a good word, yes.
Primitive. Had a little icon of a sprinkler ticking on the screen. So we really made a lot of upgrades last year. We tested this out with Ben. I had sort of a beta test site that we sent to some people. Now we have this available on the Forecast website. So anyone can go, there's a QR code there. And essentially what we're doing is we're just trying to track water in, water out, right? So we're sort of making a guess at what sort of soil you have. Do you have a clay, a sand, or a loam? And you can change that based on your site specific factors. And then we're just taking the precipitation data from your site, your evapotranspiration data from your site, making a couple adjustments for turf grass. And then we're basically tracking how much soil moisture is in that profile. And when you get below a certain level, right, and in this graph, we have this sort of minor plant stress level and then a severe plant stress level. That's what is going to trigger basically an irrigation cycle. So it's going to sort of forecast when it thinks you need these irrigation cycles. You can look at it a couple of days out. It'll say something like, "Hey, check back in 5 days when we think you may need to irrigate, right? If you don't get any rain." So you can use it for forecasting, and then you can do this retroactive thing here, like we see, where it would have said, "Hey, you needed to irrigate a lot," and this is May of last year, right? Remember, May was really dry. Hey, we need a lot of those irrigation events in May. And then you look in the summer in July, there were like 2 irrigation events, right? So the idea here is we're sort of trying to simulate a lawn scenario, but we found last year, hey, this might actually be good for, like native soil fairways, maybe sort of that swing soccer field that you're not irrigating as much. Just to give you a general idea of sort of when you need to irrigate, how often, that sort
Yeah,
of
and really, I tell you, Carl, like everything else, our work's focused on large acreage, right? There's a lot of lawns, so if people started doing this, that would make a big impact. Fairways and sports fields that get irrigated are big pieces of land, and we want to be really careful, just like we say with nitrogen use on large areas and on sandy areas, and pesticide use on large areas and sandy areas. And so, Carl and Art, I'll show you this great picture of that I saw posted the other day from a guy who went through and did some root pruning along the edge. And this is how it's looking this spring out of the gate, right? Where on the left, you still have the tree roots actively removing moisture from the soil. You see the 2 lines there. And on the other side of where the roots were just pruned, you see the really, really nice green grass. Here's a close-up of that. So essentially, you have these knives that go through the ground and slice right through the roots. And, I think we don't always appreciate what's going on in the soil, right? I think we don't always think about, like, this would be, in my opinion, a best management practice for reducing water use, right? Where you're just saying, okay, I'm just, depending on how much damage you do to the tree, right? How close you do to it. And then also, sort of how valuable the tree is to the landscape, whether you're going to cause it any trouble, and then starting to make different decisions about trees. But water management in trees, not always thought about. All right, let's see if we can wrap it up here in about 10 more minutes and just get through some of the weather stuff going on right now. Soils feel cool. They are, we were down on Long Island last week, Carl. I could have sworn we were almost into the 50s, but nobody but me thought that. Now we're going lower than that, right? Now we're definitely into the low 40s still. And I think, when I get asked sort of, okay, it's fall, spring, it's up and down, it's different. What do we think about it? I'm like, man, soil temperature, it's just like water. It's like heating up that mass. Once it gets going, it really doesn't stop, right? Art, it's like that old story about what you used to say with climate change. It's like walking your dog. Your dog walks all over, up and down, but he's walking up a hill,
Yep.
right?
Classic figure. Yep.
Yeah. So here's the interesting thing. Now that we're getting annual bluegrass weevil, in the South and further south on bentgrass, here's some scouting from a guy with the University of Virginia, in the Virginia area doing scouting. And you can see, even for 2024, we're pretty low still but there are years like in 2022 where the populations are really high, and then other years like 2021 when they're not. So this is another example of the variability that we get in trying to predict these things, and why it's important to go and look, right? Now, you could do an average on sort of where things are happening, but it's still best to go out and look. We're a ways from this. It's a little bit warmer in Virginia. Now, here's a question for you, Art. Is the cooler weather we're seeing, right, 10 degrees below normal, that's because now the lake is cool? Because why didn't this cold front, I'm looking at, it's the ocean versus the lakes. How am I looking at this for departure?
Yeah, I think in this kind of 1 week period, the last kind of week that we saw, what you're really seeing is not so much the local effects of the lake or even the ocean, but just the general weather pattern, right? We had a strong ridge over us the week previous, the early part of March, and that ridge has kind of been tamped down. So now we're getting, our winds, our predominant weather pattern is coming from Canada. And that's why we've seen this week where temperatures are somewhat cooler than normal.
Okay.
You
But
know,
not making it down to not making it down to the coast, which
yeah,
looks like it's just normal.
yeah, even what yesterday was the 27th when I was walking my dog, talking to my mom in New Jersey. She was saying it was 40 in New Jersey, and I was saying, I'm out here in a sweatshirt and it's 60.
That's
So,
very
you
interesting.
know, I think there's a case where some of that local influence came into play there. A little bit of wind off the ocean,
Yeah,
particularly at this time of year, can make a huge difference on Long Island or in New Jersey and things like that.
That's right. So as you know, we pay attention to seed head control and Art, when we've had this model in place, these two models in place for a while. There's essentially two products that people use for those that still have embark. You can see that the ideal range is in the metropolitan area, at least on the 27th. But I think when you think about a forecast moving forward, you don't see it moving very much. You see it a little bit becoming active around by April 1st, active around the Buffalo area, up into Pittsburgh and Erie, and then out into the Cape and Boston and up the Hudson Valley a little bit, but not dramatically. Still, the higher elevations, I think, are waiting to be in the ideal zone for embark. Now, for those on the proxy end, almost most of the state is either ideal or marginal right now, and moving to past. Now, thankfully, you'll see what happens in a week. It's an indication that things aren't moving very quickly, Art. Is that what you're sort of predicting moving forward? We're going to go into this stall?
Yeah, we're going to be definitely in this stall the next couple of weeks. Temperatures are generally going to be right at normal or a bit cooler than normal. We're in that pattern where, more of a trophy pattern is sitting over us. So, yeah, thankfully, if that didn't happen, the growing season would be going kind of full bore right now. But we've hit that plateau, which is good for the next kind of 2 weeks.
Yeah.
Looks like maybe going to change, middle part of not next week, but the week after type of thing. Longer range seems to be bringing the warm back.
Okay, so we'll get a little bit of a stall, and then we'll get some warm weather.
Yeah.
And what sort of that means, Art, and for you, Carl, this nice little pollinator risk model you built, and I just have a little flash here again, looking at the flowering. Why don't you talk to everybody about what we're looking at here and what this tool does?
Yeah, so I think for a lot of these sort of scheduled applications in the spring, whether it's pre-emergent for crabgrass, or in this case, we're thinking about sort of those preventative grub applications that may pose a risk to pollinators, especially with a neonic, something like midicloprid in there, trying to make those applications when we don't have flowering weeds in the landscape. And basically in turf systems, clover and dandelion are the two we're really concerned about. Dandelion, because it flowers the earliest and there's nothing else out in the landscape, and the pollinators are like, hey, there's a yellow flower, I'm going to go forage on that. And then later in the season, clover, which lasts a long time, is more nutritional for pollinators. They'll go and forage on that in lawn systems. So making sure when we make an application, let's have neither of those flowering. And it turns out there's probably a window in there, right when the dandelion's done in the spring and before the clover comes on. There's this gap where we can make that application. So we think we've got a pretty good model on timing when that dandelion flush starts, right? And that's a growing degree day sort of trigger, how much temperature accumulates during the season. And you'll see that right now, if you're looking at this pollinator model, as the yellow comes up, that's sort of when we think dandelion is starting to flower.
Yeah.
And you'll see that start to recede as we get a couple weeks, into late April and early May.
Yeah.
Then you'll see the clover come on maybe a couple weeks after. So we're trying to get you into that space of thinking, hey, when we get that gap in that window, when it's green in between those two times, that's a good time to go out and time those preventative
and again, in this model, you see not much progress over the next week in this thing. So I think, there's a lot of things to consider. We're going to come back and talk to this. I'm sure, Carl, as we get into the no mow May frenzy that will be upon us soon. But I also wanted to give you a little chance to be, especially since we've got Art here, he can see how we're talking about these tools that we've been working on in the background. here's your growth potential or your growth index. And I'm looking at this and I'm saying, you know, it may have been a mild winter, but there's been very little growth in the entire month of March, and we're really not expecting much. This is, again, taking into account a number of factors. Why don't you talk us through what's happening here? They can see this on the forecast website now.
Yeah. So again, this is, temperature. What's the ideal temperature for cool season grasses to grow? 67 degrees Fahrenheit, somewhere around there. And then soil moisture. And again, going back to that lawn watering model, we've got a pretty good way to predict soil moisture. So when that's higher, we're going to have more capacity for water to move through the system. And if there's enough heat, right, it's going to grow really quickly. And you see sort of that uptick early in March, right? We had a little bit, on 10 to 15% in the model. That's when people started getting out. It looked like, hey, we might be on to early season golf here, especially in Ithaca, start mowing a little bit. And then it really sort of shut down the last couple weeks, and mostly because of temperature, right? When you got 20 degrees, it's not going to grow anything.
Yeah. Right. Art, because the sun is where the sun is, right?
Right.
The sun, no matter what we might think, right? The sun is still in a particular position. We may get warm, but then it's like, whoa, the sun is still where the sun is.
Yep. You're getting the same amount of solar radiation, right? The only thing that's going to affect that is clouds, right? That's the only thing that would affect that solar radiation.
Yeah. Yeah. So we're not getting as much. And so when you get the normal weather patterns that we would have in March, it just feels like lately it's coming in like a lamb and going out like a lion. I was slopping around in the snow last year. Now, Carl, I want to wrap up with this particular thing because I think, especially when we were talking this morning on the conference call, and I'm thinking about the amount of materials that are applied on the spring in the American landscape, right? How the American lawn and even golf courses and sports fields in the spring, those 6 to 8 weeks when the Lowe's, Home Depot, Walmart shelves are filled with lawn products, and many professional turfgrass managers are either applying in the landscape or applying to their properties. And we actually adapted this from a pile of SHIT work, right, Carl? So why don't you talk a little bit about our little runoff model here?
Yeah, runoff risk, and in systems where they're piling up manure and they got to get rid of it in the winter, they're looking at when is a time when the ground is not frozen and when we're not going to get a whole lot of rain coming in, where we can apply that manure out onto the landscape, right? And so we basically looked at that model and said, hey, that would make a lot of sense for turf, right? We want to consider soil moisture, especially in the summer. We're not worried about frozen soil, but how much moisture is in the soil, and then is rain coming in, and what is the sort of risk of runoff based on those factors? So we basically adapted that, and now we have this tool that is essentially for, it can be for fertilizer applications, pesticides, anything you apply that has a chance of running off. Take a look at this tool, and it projects out a couple, days into the future. So
here's a good example, right, Carl? Here's a good example. Like yesterday and today, tomorrow looks good for our location. We have a number of ways of visualizing this that I really like. It's like yesterday was a hard no. And I would say if you're trying to schedule a spray day or an application day, maybe tomorrow or the 4th and 5th of next week, right? This is sort of experimental. We're trying to determine by looking at air temperature, and this is some really good data you can get from this particular model by looking at the details. It gives you a nice look at air temperature and how resistant sometimes soil temperature data at 2 inches is to the warming air temperatures, right? You don't see the same fluctuation in the soil. And also the rain and snow melt forecast that we have here. This is Art going out on a limb, predicting rainfall out almost a week, Art. I don't know how we got you to do this.
I'll admit, this is my colleagues at the Weather Service going out on a limb and forecasting that far out. You can point to this even for yesterday. I assume this is for Ithaca, right? So that, that high risk yesterday probably didn't really come about because although they were forecasting some rain with that front coming through, it never really happened.
Yeah. Which is good. And that's sort of the reason we have in the high risk bucket is we want to be conservative, right? We want to tell you high risk, and we don't want to ever tell you low risk when we end up getting a rainstorm.
That's right.
That would result in you applying and running off.
So
it's going to be conservative, right?
That's right. It's trying to be conservative because again, it's a planning tool. You shouldn't wake up and look at this thing and say, should I spray today? you should look at this thing 3 days out. And what you can also do is look at the maps. Like here's the map for yesterday, and here's the map for Sunday, right? So you can see, there's many ways to visualize this particular risk. So Carl, we're at the end. So let's do this. Let's give everybody a way to access the forecast website. We'll be sure to put it in the notes. So we talked a lot about it today. And of course, all this is all made possible through our partnership for 26 years with the Northeast Climate Center and its director, Art DeGaetano. So big shout out to Art for all the tools and all the support, we've gotten over the years, in the early years, from NYSTA and more recently from the golf course guys and the New York State Pollution Prevention Institute. It's been very instrumental in helping us out. So thank you all for joining us. Carl, why don't you take us out?
Yeah, thanks. Again, goes real quick, Frank, 30 minutes. It's by in a blur. Thanks
34, because I came late.
34. Yeah, we get to bank it. It's like we get a minute here, we get 2 minutes later. So
all right, we'll see you next week. Thanks a
yeah,
lot, Art.
everybody. See you next
Take it
Thursday.
easy.
Thanks, Art.
See you guys.
This has been a production of Cornell University. On the web at cornell.edu.